Hi everyone, so this is Miss B. I'm gonna try to do your notes kind of this way, recording them so I can talk to you at the same time as you're getting your notes. So let me know if you have any feedback afterwards. But just an update. So I'm home and doing pretty well. Our daughter we named London Paige, and she's doing good too. So I'll try to see if I can get a picture to you guys or something next time. But we're doing good. So. Starting off our new unit, so unit 2 is all about transformations, okay? And if something transforms, it changes, right? So the first thing we're going to look at there is simply the definition of a transformation. So that will be, and bear with me, I'm new on this, so I'm trying the iPad and read and talk, and hopefully it goes okay. So a transformation is changing. Okay, let's fix this. So changing a shape by flipping, sliding, turning, or resizing. I'm going to take a break right there because I guess I didn't go over. So when you are taking the notes, just try to write them with me as I'm going on your paper. And then if it's something that I want you to try, just kind of pause it on your iPad, or the teacher can pause it for you all if you want to work on it with partners. But make sure you're taking that time to stop and pause and work through it. That way, if you have any questions, you can ask those, or if you're not sure how I'm getting to that answer, that'll help you find that process, okay? So transformation, basically a change in shape. Okay, the point notation or mapping rule. So this is going to look like, so example here, it's going to look like a coordinate. So x comma y, all right, always x always first, and I'll have an arrow here. And then it's telling basically what is happening to that x value in the transformation or to that y value. So maybe it says x comma y transforms to negative x comma y. So that would mean in the transformation, all that happened was the x values of the points became negative, okay? And its purpose is it tells you what operations to perform in order to find the new coordinates. Okay. All right, so the first transformation we're going to look at is a reflection. So if you reflect something, think back to our reflection property, okay? X equals 2 is the same as 2 equals x, so that you're flipping it. So again, dealing with that flip. So reflection is flipping a shape either across the x-axis or think horizontally with that, okay? Or y-axis, so think vertically there. Right. And the important thing you need to know here for looking at your point notation and your mapping rule. So if it is a reflection, okay, I'm just going to draw a line here. I could have left some more space, but if it reflects over y, or over x, sorry, x-axis slash horizontally, okay. Then it's going, your point notation or your mapping rule is going to be x comma y to start, and then whatever one you're flipping over is the coordinate that's going to stay the same. So I'm flipping over the x-axis, so my x coordinate will stay the same and my y coordinate will become negative. So think of these as this was, the original here was that was the original coordinates, okay? And then these would be the new coordinates, right? If it is across the y-axis or vertically, which I'm running low on room, it's going to be your original coordinates, x comma y, and then transforming your new coordinates. So I'm flipping on the y-axis, meaning y is the one that stays the same, so that one's the same, and x is negative. Okay. So definitely refer back to this set of info here as we're working on these next few problems, just to kind of reinforce in your brain what you're looking at there, okay? Okay, so starting on example 1 here, so it says reflect quadrilateral RSPQ across the x-axis. All right, so the very first thing you want to do is write your original coordinates, okay? So I'm going to write those over on the side here. So R is currently 1, 2, 3, 4, negative 1. S, and this would probably be a good spot actually to pause and just get the coordinates on your own, make sure you have them accurate, because that will affect the rest of your problem. Okay, S is 1, negative 5. P is negative 1, negative 4. And Q is negative 1, negative 2. Okay, so we have all of those. Again, start off with that, try to pause as you go to check. All right, we have a reflection across the x-axis, so that's important. You can flip back up to the first slide or the first part of your notes to see what that does for your mapping rule. So the mapping rule, remember, is what tells you what to do. So if it is a reflection across the x-axis or horizontally, what happens is, here. So in that case, reflection across x means x's stay the same. Okay? And then y's become, they have that negative on there, so it looks like this, x comma y to x negative y. Okay? So if y's become negative, you can also think of it as their opposite, because if it's already negative and it becomes negative, that cancels it out, right? So y becomes negative or their opposite. Okay, so I'm going to write these new coordinates now. All right, so down here, and this R with the apostrophe, so we say that R prime, S prime, P prime, Q prime. That basically just means it's your new coordinates, okay? Looking at your originals, add the apostrophe for the new ones. So from here now I can find those. Now I know that all of the x's stay the same for an x-axis reflection, so I'm going to just fill each of those in. So R will still have 4, S will still have 1, P negative 1, Q negative 1. And I'm getting those from my original coordinates up there. All right, now all the y values become negative or their opposite if they're already negative. So in our case, they're going to become positive. So that makes R prime 4, 1, S prime 1, 5, P prime negative 1, 4, and Q prime negative 1, 2. So again, took my original coordinates, made the y values opposite. All right, and so you're always start off original coordinates, write your new coordinates, and lastly, always redraw, okay? So I want to emphasize that. Redraw. Even if the problem doesn't ask you to, it's good to do this just to check and make sure it looks accurate. Like if your shape looks way wrong and it doesn't look like the one you started with, then it's probably wrong. So let's graph this now using our new coordinates and see what we get. So 1, 2, 3, 4, 1. Okay, label them with the new, so that's r prime. Okay, s is 1, 1, 2, 3, 4, 5. S prime. Okay, p is -1, 4. P prime. And then q prime is -1, 2. Right, and I just connect my points. Okay, so our new shape from the transformation should be the same, should be congruent to our original shape. So if you draw it, they don't look congruent, then something is wrong. You need to go back, check over that, and make sure, see what you did, okay? But there's our first one. Sorry, having some difficulties here. Hold on. Okay, there we go. All right, so for number 2, so reflect quadrilateral RSPQ across the y-axis. So since it's a y-axis reflection, that changes things a little bit. That will make our x values become negative or the opposite, all right? And the y values will stay. So x's become negative / opposite, and whatever you're reflecting over stays. So y's stay the same. Okay, so typically I would say write your original coordinates. However, we do already have those from the first problem. They stay the same throughout these examples. So I'll write them real quick. So r is 4, -1. S is 1, -5. P is -1, -4. And Q is -1, -2. Okay. So second, find our new coordinates and using that mapping rule that we have from up above. So x's become negative or opposite, y's stay when it is a reflection across the y-axis. If you ever don't know what the mapping diagram is, just honestly look at it and eye it, because that can get you a long way. So if we're reflecting across the y, okay, so that's right here. All right, so I want to make sure that looks like that's what I'm doing. So I'll start with the coordinates, but then I can kind of show you what I mean by that. Whoops, don't need a ruler. Okay, so x's become negative, so all of these become their opposite. So pause the video here and see if you can find the new coordinates down here. So we're looking for these using this rule, okay? So hopefully you've paused to see if you could get them. You should have gotten -4, -1, -1, -5, 1, -4, and 1, -2. Okay, so y's stayed the same, x's became their opposite. All right, third step is to, well, we wrote our new coordinates and now draw them. Always redraw, remember. So -4, -1. Let's plot that. 1, 2, 3, 4, -1. And that'll be r prime. Oops. Okay, -1, -5. 1, 2, 3, 4, 5. Okay, that is S prime. 1, negative 4, that's P prime. And then Q prime is 1, negative 2. Right? You can connect them because it's hard to tell if you're not connecting them if they're in the right spot. Alright, again, shape should look congruent, and it should look like I took that original shape and I flipped it over onto the left, which this one does look like that. You can also kind of check by seeing, so like R is 1, 2, 3, 4 spaces from the y-axis, whereas the original R was 1, 2, 3, 4 spaces from the y-axis. So if you ever get stuck and you're not sure how to do the mapping rule or to find these new coordinates, kind of do it like that. Okay, R is 4 from here, so if I'm reflecting across y, it needs to be 4 from it on this side. You can just kind of eye it and see if you ever get stuck. There's no reason you should have any blank answers when it comes to these transformations. Okay, you should be able to find something for sure. So, all right, so, whoops. Don't need that line. Flipping to our next one. Okay, so number 3, reflect quadrilateral RSPQ across the line x equals 1. Okay, these are a little bit more complicated when it's dealing with x equals something or y equals something instead of just the x or y axis. But we still do want to think like, is it a horizontal or a vertical transformation? Like, how are they, a reflection, how are they flipping that basically? Okay, so still have our original coordinates, all right? So I'm going to write those down for you guys, but so that's so R 4, negative 1, again, same from the top. You don't need to rewrite them on yours, I'm just writing them so you can see. Okay, so those are our originals that we have down here on the graph. Okay, so for this one, x equals negative 1 is what they're flipping across. So I'm going to show you where that's at. X equals negative 1, or 1, sorry, is a vertical line, okay, because x is right here. So I'm looking at, it's really thick, this line right there, okay? When it comes to this, so it is still a vertical transformation, okay, because it's flipping that way. All right, but we also have this space right here of it's 1 away from the y-axis. So it's not just the same as flipping across the y, it's 1 away from that as well. So we have to change that mapping diagram just a little bit there, okay? So how that affects it is, first of all, on that, it's a vertical, so that means that the y's stay, x's become opposite. So x's opposite, y's stay, okay? So all of our y's, there, those will be the same, okay? So I can go ahead now and copy those down here. So negative 1, negative 5, negative 4, negative 2. All right, but the x's is what's going to be different here, okay? So first thing we know is they're opposite. So 4, 1, negative 1, and negative 1 all become opposite. But since this reflection is 1, it's x equals 1, so it's 1 space away from y, all right? Well, if we were taking this whole shape here, all this, and reflecting it across over to this side, that means it's also going to be 1 away on this side, okay? So we're actually accounting for 2 spaces here. So our mapping diagram, okay, usually it would just be x comma y transforming to x's become opposite because it's a vertical, so negative x, and you can think vertical, it goes along with this y-axis. So negative x comma y. We do that first, right? But since there's that other additional part, it's 1 away from the y-axis, okay? But it's also 2 times that since it's on each side when it's a reflection, okay? So it's actually going to make our mapping diagram be negative x plus, accounting for that space, 2 times how far it is from the y. So 1. It's 1 space based on this from y, plus 2 times 1, comma, y is staying the same. Okay? So you're basically going to do that for each of these. So if I have r, the x value is going to become negative, so that's negative 4 plus 2 times 1, and then y stays the same. So negative 4 plus 2 times 1, so that's just 2. Negative 4 plus 2 is negative 2. All right, so that's done down here. Okay, now s. Okay, s is 1, but I need to make it opposite based on this, so negative 1 plus 2 times 1. Okay, so negative 1 again plus 2, so that is positive 1. And I would pause here and go ahead and see if you can find P and Q to finish those off. So hopefully you paused. So P would be make negative 1 opposite, so that's positive 1, again plus 2 times 1. And these are just the x values. The y's are staying the same each time. I just hadn't been writing them. So, okay, that one gives you positive 3. And then Q, negative 1 becomes its opposite, plus 2 times 1. Y stays the same, so it's 1 plus 2, again, 3. All right, so we got our originals, found our new coordinates, and lastly, remember always find or redraw and see if those match up, okay? So r is negative 2, negative 1, so that's r prime. S prime, 1, negative 5. 1, 2, 3, 4, 5. So S is actually in the same spot, so I'm still going to label it separately there. But P, 1, 2, 3, negative 4. And if you're noticing that vertical reflection, these are still kind of these points are in line with the originals. And then Q would be 1, 2, 3, negative 2. That's Q prime. Connect your points, otherwise it's hard to tell. Okay, so again, look, make sure they look congruent, make sure it visually looks accurate, right? Okay, I'm going to go to problem 4. All right, again, reflecting RSPQ across the line y equals negative 2. So have our original coordinates, r 4, negative 1, s 1, negative 5, p, negative 1, negative 4, and q, negative 1, negative 2. All right, and I'm going to just show you over here, y equals negative 2. If we're finding that line, try this one. So y equals negative 2. So y is our up or down, right? Negative 2 is down here. Oh, that's not very bright. So this is the line we're reflecting it across, all right? So think, right, is that a horizontal, like an x-axis reflection, or is it vertical, like a y-axis reflection? So This one is in line with the x, so that's a horizontal or an x-axis flip, meaning our x's are going to stay the same and our y values are going to be the opposite part, okay? So I can start with that. Let me get down here. Oops. Okay, so like I said, x's stay the same. So I'm going to copy down 4, 1, negative 1, negative 1. And remember getting those from up here. So x's stay, y's opposite. Okay, now we want to look, all right, if we're taking our y values, so here, 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 and here, first we want to make them opposite. So if I'm solving for r, okay, opposite of negative 1 is positive 1. And again with that mapping diagram like we did before. So our originals are just x comma y. If they're transforming, in this case we said x's stay, so I'll just write x because nothing's happening to it. For the y, so it's opposite, so I make that negative y. And then I'm always going to add 2 times whatever this reflection spot was, reflection location. So that's going to be 2 times negative 2, all right? And remember, we're doing the 2 times it because since it's a reflection, it's 2 away from it on both sides. Like it'll be 2 on this side of the x-axis and 2 on that side of the x-axis, right? Which actually is making it 4 away. All right, so down here, like we said, opposite of y, so that's negative 1 becomes positive, plus 2 times negative 2. And you just kind of solve that there. Calculator in your head, either way, just make sure it's accurate, all right? So 1 plus, it's going to be 1 plus negative 4, which is negative 3. We already have our x, all right? But now I can just write down my y. Okay, I would pause here and try to see if you can find the y values for s prime, p prime, and q prime. Okay, if you stopped and paused, you should have made 5 its opposite, which is negative 5, and then plus 2 times negative 2. Okay, so, right, that's, oops, hold on. Give me just a second here, lost my spot. Oh, there we go. Forgot that negative up there. Sorry. So positive 5 plus 2 times negative 2, which is negative 4. Erase that a little bit. Maybe. Okay. So 5 plus negative 4 gives you 1. All right, write that down here. All right, p. So opposite of its y value is positive 4 plus 2 times negative 2. So that's 4 plus negative 4. Opposites add to cancel out and equal 0. All right, and then q. Opposite y value is positive 2 plus 2 times negative 2. All right, so that's going to give us negative 2 for the y value. Okay, so we have our 4 points. Last step is always to redraw. So let's check that. So I got r is 4, negative 3. 1, 2, 3. So r prime. Remember here, if you are not sure how to get this part over here, draw this line that you're reflecting, so our yellow line, and kind of eye it. So if r here is 1 away from the line, r prime should be 1 away from the line, okay? Here, q is right on the line, so that means q, this is going to be q prime as well. So it's going to stay. P is 2 away, all right? 1, 2. So p prime, and let's check that. So p prime, negative 1, 0. Yep, that was right. Q, negative 1, negative 2. Yep, that was right. All right. S is 1, 1, S prime. All right, but so like I said, if you get stuck, that's a way to kind of check. Make sure you're labeling these with the prime, the little apostrophe, because otherwise you might get confused on which, like I just did there actually, which point goes where. I'm drawing to the wrong one. Because it gets a little confusing since you do have the same letters, okay? So, in blue is my new transformation. So again, make sure it looks congruent. It does. That gives a good indication that it was correct, okay? Okay, so to finish off this page, I think I already did this part up in the question on 1 through 4, but it says to write the mapping rule for each example above here, and you will have to do that some on your test and stuff. That is the part I wrote, like x comma y, arrow, blah blah blah. So on the first one, we just did x comma y transform to, it was a reflection across x, all right, which means again x's stay the same, y becomes opposite, so negative y. So that would be your mapping rule. If it's asking for that, that's what it wants. For number 2, always start off with x comma y. Okay, that's just your original, whatever the coordinate was. Then it's becoming, it was a y axis reflection, which means x's change, y stays the same. 3 was that one where it got a little more complicated. So x comma y, we had a reflection, so that makes on the y, so it makes it negative x, and then we gotta do that complicated part, so plus 2 times 1, and y stayed the same, okay? And then lastly, number 4, x comma y, always to start. 2, it was a reflection in line, like a horizontal or in line with the x-axis, meaning x will stay the same, and then y becomes opposite, so it's negative y plus 2 times, since it's a reflection, it's double the distance, and then whatever we were reflecting across. So in that case, it was negative 2. Probably could have done brackets there, but that's okay. Okay. Oh, hold on. All right, so, and on the second page of your notes, so translation, these are definitely the easiest. So a translation is a slide. So, and I got this little cut off up here for some reason, but hopefully you can see where I'm at. So it's under translation. It is sliding a shape left, right, up, or down on the graph by either adding or subtracting from the coordinates. Okay, and so the point notation or the mapping rule, so that's the x comma y part that we did previously, is you either add or subtract from the coordinates, like we said over on the left there. So up and down, so if it says like move 2 up, let's say up and down, well, 2 up affects your y values, okay? Up and down affect y values. All right, if it says left or right, that's going to affect your x values. So let's start off here, number 5. So find the image from the rule. So here they're giving you the rule and they want you to perform that and tell what those new coordinates are, all right? Again, I need to start off with knowing my coordinates. So usually they will not give these to you. You have to look in there and find them. So I'd pause the video here and write down the coordinates for W, U, and V. So hopefully you paused. W, you should have gotten 0, 3. I'm going to do a lowercase u so you can tell, but that should have been 1, 2. And then V, 3, 5. Okay? So now I look at my rule. So this tells me what to do to each coordinate. So I'm going to do W a little more in depth than the next two, just to kind of really show you. But so if W is 0, 3. So that tells us I take my X value, which is 0, and I minus 3 from it. And then the Y value is 3, and I'm going to minus 4, it says. All right, well that will give me W, 0 minus 3 is negative 3. 3 minus 4 is negative 1. Okay, now I have my new coordinate, which can go down here as well. Okay, and go ahead and plot that. 1, 2, 3, negative 1. All right, that is W prime. Didn't write that there. Okay, do the same thing. So again, I would go ahead and pause, find U and V by doing what I just did, X minus 3 and Y minus 4, okay? All right, so U, you should be using 1 minus 3, and then 2 minus 4, all right, which comes out to, right, in the right spot, yeah. Oop, minus 3. I knew there was a mistake there. All right, so negative 2, and again, negative 2. And then for V, you should have done 3 minus 3, which gives you 0, and then 5 minus 4, which gives you 1. Oop, prime, prime. All right, plot those. So negative 2, negative 2. Oop. So here's U prime, and then V is 0, 1 for V prime. Connect those. Okay, and it looks about the same size, looks congruent, doesn't look like a crazy different shape, so that gives me a good idea that that one is correct, okay? All right, number 6, write the rules shown below. So here, they give you the shapes. They want you to tell the rule, which is what we had over here. Okay, that's what they're looking for when they say write the rule. So start off, look at your originals, okay, and just see what happens. And it really doesn't matter which point you pick. Like if you want to look at the S's or the T's. However, you can't compare S and then U because those weren't in the same spot to begin with. So it's kind of like the corresponding point here, all right? So I'm gonna just look at S because that's the first one I saw. So S, and you can kind of do this, right? Like if you remember doing slope where you would kind of draw between there, if that helps you, do that. So from S original here to S prime, I went up 2. So that's up is positive, that's plus 2, okay? All right, and then our left and right, so and that affects our y's, the plus 2, y is plus 2. All right, going left to right, that means it's x, dealing with x there, and that's 1, 2, 3, 4, 5. So it's 5 right. If it is right, then that is plus 5, all right? And now I'm basically just gonna plug that into our mapping rule. So I'm gonna do always start X, Y, that's your original. Start with that. So if nothing else, you should get that. And then X plus 5, I'm putting the 5 instead of the 2 since that's what's affecting X values, all right? 2 has to do with Y. and then the y, so again, this tells the change. What is the change? Each point went up by 2, so that's y plus 2. So just to remind you, up 5, oops, up 5, right 2. That's where those came from. All right. Okay, and so a couple different questions here at the bottom. So find the perimeter of the image you found in example 5. So if you're looking at 5, you need those coordinates, and they're wanting the new image, all right? So we're going to find the distance of each side. So this is really kind of thinking back to when we did distance in unit 1A, okay, where we did the triangles, we found the perimeter, all that. So I'll show you the first one, and then I want you to do these because it's definitely a key thing you need to have memorized, okay? So find the distance. And if you remember, that's where we do our square root. So you are going to need to find the distance of line segment WV, VU, and UW, okay? Like I said, I'm going to do WV, and then I want you to do UV and UW, or VU. So WV, the points were -3, -1, and then 0, 1. Okay, I put that into my distance formula. All right, first part, I do the distance between the x's. So -3 to 0, that's 3 apart. I square it, plus distance between the y's. -1 and 1 are 2 apart. Please use your calculator if you are struggling on those parts, okay? All right, that simplifies to 9 plus 4, which is the square root of 13, which is approximately 3.6, okay? All right, go ahead and pause the video here and see if you can do VU. So write the coordinates for VU, and then UW, and find the distance just like I did on this first one of each of them, okay? Just a reminder, you should be doing this part on your own. I'm just writing it so you can check it when you're done. So this should be paused. Okay, so hopefully you paused and did your work, and now you're checking it like good children. So I have each of my sides, okay, but perimeter, of course, we need to add those up, all right? So if I'm adding those up, that gives me 16, 6, 7, 8. Okay, so perimeter equals 8.6. We aren't given a measurement, so let's do units. Okay, and it also says, so reread your question, remember, what could we say about the perimeter of the pre-image? So the pre-image is just what you started with before you did the transformation. So since I said those should be congruent each time, it's not changing the size, it's only changing its location if it's a translation. So think about for a sec, talk to your neighbor if you need, what could we say about the perimeter of the pre-image? So pause it if you need. What you should say is that the perimeter will be the same because, again, it didn't change the shape, or it didn't change the size, it just changed its location. It took it and it slid it down. Okay? All right, sorry, these notes are kind of long, but we're there. So original image is at the coordinates x, y, z. You can read those. Find our new, so x prime, y prime, z prime, by reflecting over the x-axis, and then find, so this is x double prime, y double prime, z double prime. Just means you did, this was your first transformation, and then you did a second one, okay? By then using this rule, all right? So take this one step at a time. So our first one, it said it was a reflection over the x-axis. And I have my original coordinates here, so I'm going to write those out just to -3, 1, -8, -2, -4, 5. Okay, so I'm reflecting it first. And that's x-axis. All right, if I reflect over the x-axis, that means my x values are staying the same. All right, so if I had to do the mapping rule, it would be this. X comma y, I said x's would stay the same, so x same, y's become opposite. If this helps you each time, it kind of helps me like remind me what I'm doing to my coordinates. So then my new coordinates here would be, so x prime is going to be, x's stay the same, so these are all the same. -3, y's become opposite, so -1. And I would pause here and make sure you can get these. If you've paused and are now checking, so y prime should be -8. Y becomes opposite, so +2. And then, oops, I don't know how that happened. Z prime, -4 stays, 5 becomes opposite. Alright, so we did the reflection there. Now we need to do the second part, which, looking at this, if it's just adding or subtracting, that's just a translation. So it means they just took those coordinates, they took that shape, and they slid it on the graph. So our second part, so translate, or translation, either way. Just writing that so you see that different. I'm going to work though, because it said, and then find, so first they did this and then they did that. So I'm going to work from these coordinates here that I just found, not the original, okay? So if I'm translating, I'm doing this to each of them. So that's going to be x double prime is -3 plus 9, all right? So that gives me 6. And then the y, I'm taking -1 plus 2, which gives me +1. I'd pause here and try to find y double prime and z double prime. Okay, hopefully you're just checking now. You should have gotten 1, 4, and 5, -3. Okay. All right, 9 and 10. 9 is super easy. So describing words, what is happening to the figure given the rule x comma y transforms to x minus 4, y plus 7. So if you're describing a word, they just want you to tell what does this mean and what does this mean, okay? So x minus 4, all right, well that tells us, think x is left or right, all right? So negative, that tells us it's moving left. So I could say the figure is moving left 4, and y plus 7, so y is up or down, positive would be up, so I'd say and up 7, that's all. Okay, and number 10, write the rule, so our x comma y arrow stuff, that would translate a point down 2 and right 3. So start off, x comma y arrow. Right, then I still have my x, so I want to think here, down 2 or right 3. Which one would go with the x? So you should have thought the right 3 part. this one's y. All right, so right 3, right is positive on the graph, so plus 3. And then for my y values, it says down 2, down is negative, so negative 2. And that's that. Okay, so again, I know this was kind of long, and it was my first time doing it, so hopefully it went okay. And if you guys have any feedback or any thoughts on what I could do differently to help you out for next time, just send me an email and let me know. I've been still kind of responding to those, so should be able to get back to you. Okay? All right. Hope you're doing good. Bye.